right? And so it's 5 divided by R minus G, should get 1083 and so on. All right, the next one, we have our year one is $5. It grows at 20% for 5 years. So 1 year, 2 year, 3 year, 4 year, 5 year, 5 years of growth. And then after that, it grows at a rate of 0. In other words, it doesn't grow. And so how do we value this? We go to the year when you saw your first of the constant rate cash flows, in this case dividends. Okay, go back 1 year, place your horizon value there. So it's equal to the next dividend divided by R minus G. So in this case, it's just, pardon me? So it's 1244 divided by 10%. So it's the next dividend divided by R minus G. And then I add the horizon value to dividend 5 to get cash flow 5. And then cash flows 1 through 4 are just dividends 1 through 4. And we just take the NPV of all of these. Now I don't know what I was thinking about. I just did them all at once, but you certainly wouldn't have any issue saying equals NPV. Click on your rate, comma, and just highlight the cash flows. That works too. Whoa, what happened here? Yeah. This is correct. I'm not sure. Oh, you know what? I bet I have. Let's see what this does. Oh, that's why. All right, now it won't happen. So, oops, NPV 0.1. I think this should work. Well, look at that. What's going on here? What is this one? Oh, I see. I thought I fixed that. I didn't. There we go. Not sure what this is about. All right, anyway, there you go. 104.50, one or the other, however you did it. All right, redo all this with a discount rate of 7%. So the perpetuity is $10 divided by 7%. The constant growth is $5 divided by 7 minus 4, R minus G. And then we redo these series of dividends, and you only have to make 2 changes. One to the horizon value, and then change your discount rate overall. And I get 156.50. All right. So any questions on that one? Oops, I got the wrong one here. My fault. Excellent. Okay. So I don't see any questions. Let's go to question number 20. All right, let me read 20 to you. There's a great deal of confusion on the timing of this. All right. It says here that current book value per share is $50, right? Now, you remember when we created in class table 4.4, we started out with a value in year 1. Okay, so for problem 20, that value is 50, not 10. It's the same kind of a thing as table 4.4. So we start out at 50. It earns 14%. It pays out. It earns 14%. It pays out half, and so earns 7, pays out half of that, 3.5 as a dividend, and retains 3.5. So 3.5 goes to your ending book value. So the ending book value of 1 year is the beginning book value of the next. So we just continue this process just as we did in table 4.4, except this one begins constant growth in year 5. So in year 5, the ROE drops to 11.5%, and the payout ratio is increased to 80%. All right. And so for my cash flows, I have the first dividend, the second dividend, the third dividend. I have the fourth dividend, and then we'll be taking horizon value 4, which is D5. This is D5. All right. Divided by R minus G. All right. And so we'll divide by R, 11.5%, minus G. And in this case, we are retaining only 20% of the earnings. So therefore, the growth rate, B times ROE, is just 2.3%. All right, so I can show you that. So you're retaining 20, and your ROE is 11.5. So it gives you a growth rate of 2.3%. And so that's what's in my horizon value. I add the horizon value 4 to D4 to obtain cash flow 4. So this is cash flow 4, cash flow 3, cash flow 2, and these are what? These 3 are exactly equal to the dividends. And then cash flow 4 is the sum of dividend 4 and horizon value 4. Gives me this number. And I discount these back at the cost of capital, 11.5%. And I find the value to be 54.22. So how are we so far on that one? Anything I should redo, or is that okay? All right. I don't hear a question. I have to assume this is just, I know exactly what I'm doing. That's what you're telling me. All right. All right. Now the next part says, what is, part B is, what is Q stock worth? How does the value depend on the payout ratio and the growth rate after year 4? Well, I guess we could do some derivation type work, but why should we do that when we have Excel right in front of us? Okay, I have a value of 54.22, and right now I am paying out 80%. Well, what will happen if I pay out 60%? Okay, how will that 54.22 change? Well, let's see, I'm paying out less, the value should go down, right? Oh, shucks, Jethro, that stayed the same, didn't it? Well, let's see, maybe I did the wrong thing. Let's go to 90%. It stayed the same. Well, surely there's something wrong here. Let's go 20%. 20% payout. Stayed the same. What's going on? And now watch these as we keep doing this. Let's do back to 80 for a moment. Now notice this yellow number, the horizon value. That is not changing, is it? So how does the payout ratio, let's go back to the question, and the growth rate for year 5, it doesn't depend on those at all. Why not? Well, it's because, excuse me, at that point, we have R and ROE are exactly the same. So ROE and R are the same. Therefore, we cannot create value. So the payout doesn't matter. Now, the only one you can do wrong here, and it's not exactly wrong, but you're going to create a division by 0. If you, I think it does, is it? What happens if I don't pay out anything? Yeah, I get division by 0 over here. Yeah, because you're getting 1115 minus 1115 in the denominator. So if you even make this just even 1%, as you can see, the price still stays at 54.22. The horizon value remains at 65.54. Okay, and that's all related to R and ROE being the same. Okay, how are we on this one? Any questions?
Yeah, I have a question.
Yeah, please.
So just making sure it's only when ROE equals R that that ratio isn't going to affect it, right?
Yes.
Okay.
Well, nothing changes when you have R and ROE the same. I mean, you can't create any value. Now, let's try another scenario here, just to kind of show you what's going on here. That's a good question. What if I, let's see, this is my ROE and this is my R. There we go. Okay. What if I have the discount rate at 13%? Now what happens? Well, now you're starting to destroy wealth, aren't you? So now you have ROE less than R, and that's when you start to destroy value. Okay, so on the other hand, what if R is only 6%? Now watch what happens. What's going to happen to that 54.22? It's going to jump way up, isn't it? There you go. So we have the three scenarios there. R equals ROE, which is what we started with. Creates a no growth environment, no extra value created. And then we have ROE. We had an R greater than ROE, and we destroyed wealth, and now we have an ROE exceeding R, and we're creating wealth. So that's kind of where we are right now. Did I answer your question?
Yeah, thank you.
Yeah, you're certainly welcome. Everybody hear that question? It's a good time to speak up. If you have a question like that, just ask. It's fine. All right, here we go. Let's continue. Problem 23. Now, this is just a recreation of the lecture notes with R as 12% instead of R of 10%. That's what I did in the lecture notes. So if I change this to 10%, that's exactly what we did in the lecture notes. Change this back to 12, it's the problem. Okay, so question number 1, calculate the value. You should get a value of 23.88. Okay, we have, and the cash flows are right here, same as we had. We had a 50-cent dividend, a 60-cent dividend, followed by $1.52, followed by $1.24. Now you're going to get a little bit different number here if you type in dollar amounts instead of referencing cells. It'll be a little bit different. All right. So here's my horizon value. It was $1.24, and in class we did 10% minus 8. Here we're doing 12% minus 8. We get 31,104. And then if I were to take the present value of this 31,104, and I did it right here, at 12%, so I discount it back 3 years at 12%, the present value of the horizon value is 2214. And what part of the value of the stock is the result of or comes from the horizon value? And you can see that the share value is 23.88. the present value, the horizon value. So what part of this is from the horizon value? Well, it's 2214. That's about 93%. Okay, so you have to be very careful in choosing horizon value if it's going to be that close to today. If it's only 3 years out, it'll have a dominating effect on the price you get. All right. So let's continue. What part of the value reflects the discount? Oh, we did that. Sorry. Next page. Part C. What part of P3 reflects the present value of the growth opportunities PVGO after year 3? Okay, so this is P3. What would the value of the company be in year 3 if it had no growth after year 3? Well, that would be EPS 4 divided by R, and that's 12.488. That's right here. Here's your EPS row. EPS 4 divided by R, which is 12%. So it would be worth 20.74 after year 3 without any growth. And since it's worth 31.10, is P3 is HV3, same thing. Then the difference is the PVGO, which is 10.37. And if you just said that, that's fine. It's about a third of the value, isn't it? But if you just said it's 10.37, we'll live real nicely with that. All right. All right, then the next part asks, what if after year 4, all of the growth potential for the company, let me read it, that way I can't screw it up. So suppose the competition will catch up with growth tech by year 4 so that it can earn only its cost of capital on any investments made in year 4 subsequently. So if you earn only your cost of capital, that means that ROE and R are the same. That means G is 0. So you've lost all of your growth opportunities. All right. And so what that means is that dividend 1, dividend 2, dividend 3, but then horizon value 3 no longer includes the 10.37 for growth. That's gone to 0. So horizon value 3 drops to 20.74. If I add that to dividend 3, I get 21.89 or so. Okay, and that's what I have here for my cash flows. So 50 cents dividend 1, 60 cents dividend 2, and then the restated cash flow 3 would be the year 3 values and no growth plus dividend 3. That's the 21.89. And if I discount these back at 12%, I get 16.50. Or I can take the price that I have now, 23.88, and let's take out the part that changes. So 3 years from now, the company will be worth 10.37 less. So I can say equals 10.37 divided by 1.12 raised to the third. It says it's worth 738 less. I'll take the 23.88, subtract the part that's no longer there, and I get the same 16.50. So we could do that either way. All right. Do I have any questions on problem 23? Okay, let me go in here. So any questions on problem 23? Okay, let's move then to 24. All right. I laid this out in the lecture notes, but let's just redo a lot of it. Implied by the dividend discount model, the discount rate is the same as, and what are the two parts here again? It's the dividend yield plus the what? Dividend yield plus the growth rate. Right? And so we have a D1 over P0. And then for the growth rate, we have ROE times, you know what, I have the plowback ratio here. I say PB, but in the notations that we've been using, this is just a small b, isn't it? So maybe I'll do that. Just try not to confuse anybody. So the dividend yield plus the growth rate. So the dividend yield is a $4 dividend expected on a price of 100. And then the growth rate is ROE, 10% times B, which is 4%. So now we have 4 plus 4. That gives us the 8%. I think he told you that anyway. All right. And then the next question is, okay, what is the expected long-run rate of return from the purchase of the stock at $100? We did that. What part of the $100 price is attributed to the present value of growth opportunities? All right, so there's just so many ways we can do this. Let's pick the easiest one of the bunch. Our price is 100, and let me just delete these. What is it worth? There's two parts to it. We want to know we have the value as a no growth plus, I'm going to do that, plus PVGO, and that's equal to the price, isn't it? Right? So I know the price, that's 100. Can I value this as a no growth? Well, yes. I'll take the, let's continue this equation if I could. Oh, it is EPS 1 divided by R, that's the value as a no growth, plus PVGO. Right? Price we know. Okay, EPS 1. Well, if you're paying out a $4 dividend and you're paying out 60%, so how do I get 60%? That says 40. What did I do something wrong? No, it's a 40% plowback. So it's 1 minus B, isn't it? So this is actually equals, and that would be dividend 1 divided by 1 minus the B. Okay. And what does 1 minus B equal? Give me another word for 1 minus B. What does that equal? What do you call that? Oops, not double. B is the first class session. First thing I showed you were the two homes for earnings. Paid out or added to retained earnings. If B is the part that is paid out, 1 minus B is plowed back. This is your payout ratio. So therefore, $4 dividend is the result of paying out 40%. So I just do that backwards. $4 divided by 60%, I get earnings of 6.67. Value is a no growth. Divided by R. That's the first part here. And I divide that by 8%. And this is actually 83333. I had not rounded this. Like, we can kind of cheat here a little bit. Let's do it. There we go. So there you go. It's 833. Anyway, you subtract a number from the price and you get the growth opportunity. 1667 is just right. There's a few other ways to do it, but we're not going to worry about those. Just do it the easy way. That makes sense? Do it the easy way. You know the price. This is a very easy equation to find this value, subtract, and you get this. All right, now the rest of this is not so easy. Right? We know that D1 was $4, came from earnings of 6.67. Part B, we change the script. The story changes. We'll now be plowing back 80% because the company has to expand for the next 5 years. For the next 5 years, we will plow back 80%. Our ROE continues to be regulated by the Public Service Commission at 10%. And then 80% times 10% gives us a growth rate of 8%. So if I know this first dividend, how do I get the second one? Well, just our earnings, I'm sorry, times 1.08, right? It'll be growing at 8%. Okay, how do I know the payout? So the dividend of the 667, they're going to pay out 20%. They're retaining 80, they're paying out 20. And I just copy these down, so we'll do this for okay, the next 5 years. 1, 2, 3, 4. Then at the end of the 6th year, we will return to paying out 60%. Okay, so this dividend, starting in year 6 on, now a couple things happen. Let's take out this 1019 number for just a moment, and I'll show you how I got it. What happens from year 6 on? Well, now we're growing at, we'll take the above value, 9.8, times 1 plus, and since we're paying out 60%, we're retaining 40, so B is 40%, times ROE, means that we have an effective growth rate now of 4%. So from this point on, these earnings will grow at 4%. From this point on, these dividends will grow at 4%. So this is my first dividend in the constant growth stream. I go back 1 year, set my horizon value, excuse me, set my horizon value. And how do I get this? Let's do this one again. It equals the next dividend divided by, and what will our rates be? We're using a cost of capital of 10%. Sorry, my fault. Of 8% minus the growth rate from year 6, 7 to infinity, which is 4%. All right, and then cash flow 5 will be dividend 5 plus horizon value 5. That's your cash flow 5. Dividends 1, 2, 3, and 4 will be cash flows 1, 2, 3, and 4. And if we discount these back to present value at 8%, we find the value of the company stock is 106.17. Excuse me. Now, one thing that this question, in my opinion, failed to ask was we automatically, as if we were commanded on cue, take on this adjacent community's sewage. Does this company have to do that? No, they don't have to do that. How do you know if they'd want to? We just calculated the cash flows that would result. How do we know whether or not the utility should take on the adjacent community sewage? Well, I can answer that in about a half a second by looking at the numbers. What did we just do? What is this? That's the price that will result if we take on this adjacent community sewage. What's the price right now? It's $100. So if we take on this adjacent community sewage, we will increase share value by $6.17 a share. That's how you know you should do it. And I think the question would have been well served as to whether or not they should do it. I mean, don't you just automatically do things? I mean, it should be an NPV analysis, and we've just done that. And now we know that we should do it. But up until this point, this wasn't something that we knew we should do. Okay, but once we see this 106.17 compared to our current price of 100, it becomes worth it, doesn't it? All right, the number 29. Okay. I got you pretty close to this point in the lecture notes. Basically, all you need to do is divide both sides by book value per share, so the price to book, ROE times 1 minus B divided by R, and that by itself doesn't look that neat. But if you divide numerator and denominator of this part by ROE, what happens? The ROE in the numerator cancels. R will be divided by ROE. The ROE that's multiplied by B will also cancel. And so you get this equation right here. All right. So there's three conditions. R equals ROE, R less than ROE, R greater than ROE. Let's start out with the easy one, R equals ROE. If R equals ROE, then I hope you can see that R divided by ROE, this will be a 1. This whole fraction becomes, now that's my third option here, becomes the same as 1 minus B, so you end up having 1 minus B divided by 1 minus B, so you get a 1. Okay. What do you want this price to book ratio to be? Would I prefer 10 to 1? Would I prefer 20 to 1? What's a good price to book? Well, the larger the better by all means. Book value per share. Open the accounting statement, the balance sheet. Add up all of the items in the equity section. Divide those by the number of shares. You know, I have book value per share. Okay, big deal. I can do that. I took an accounting class. I did that. What does it mean? Okay, that's on a share value, what your shareholders have contributed to this company since the start. So since day one of operation, that book value is all the dollars that shareholders have contributed. All right, now what if I today asked you, each of you, to give me $100 and I'll start a company? What would you want me to do with that $100? Just give you back 100? Well, you'd hope to make something on it, wouldn't you? So what if after the end of 1 year, that $100 you gave me, you could sell your share for 200? You'd be very happy, wouldn't you? Okay, so yes, you always want a price to book to be greater than 1, for sure. You want those dollars of funding that you as a shareholder have contributed to this enterprise to be worth more than what you contributed. Otherwise, the management of that company has done nothing with your money. All right. So how can they create value? A positive price to book. Well, what this shows us, if you go through this equation, it shows us that If ROE is less than R, then this ratio drops to less than 1. If ROE is greater than R, the price to book exceeds 1, which means that they are creating value for you. Here you're destroying value. And then the last one, if the price to book is exactly 1, then you've neither gained or lost in this company. Now what else? Excuse me a minute. Oh, never mind. I can't do it. Here we go. Okay, I'm sorry. I take a pause every so often to blow my nose or cough very loudly. What happens once that price to book starts to get very less than 1? What do you think happens? I don't know if you've ever been real tired some night and just watched whatever dumb movie's on, and one of those movies happens to be might happen to be Pretty Woman. And sure, it looks like a love story on the outside, but what it was, that was a story about a corporate raider. And this was about a guy who finds companies that are selling for less than book value. So he buys them for less than book value and then sells the assets and keeps the difference himself. So he destroys companies. Okay, so once your price to book gets to be less than 1, you become more valuable dead than alive. And then that's when the corporate raiders will come in and destroy the company. So there's a couple of reasons to keep price to book over 1. One would be that you'd like to show some positive gain from your investment if you see some positive gain from your investment as a shareholder. And number 2, that some corporate raider doesn't destroy your company. All right. So do we have any questions I can answer about chapter 4? Any of the questions?
Yeah, I have a question quick. Can
Please.
you just quick show the equation or what you did to get the total cash flow for year 5?
In which problem?
Sorry, problem 24.
Okay. Yes. Okay. Do we have these dividends? Okay. So then with the horizon value. Okay, I go to the next dividend. Let's do this one from scratch. I go to the next dividend. So I'm putting horizon value in year 5. So I go plus 1 year, D6, divided by, and then it would be R minus G. So that would be, we've used an 8% cost of capital. And then at this point, from dividend 6 onward, that's the growth rate we have to subtract here, not anything that happened up here. From dividend 6 onward, we are retaining 40% against an ROE of 10, which gives us a 4% growth rate. So I will subtract 4%. Okay, and that gives me the horizon value of 146.93. I add that to dividend 5, and that gives me cash flow 5. Is that what you are asking?
Yes, thank you.
Okay, is that clear? Do you understand what I did now?
Yeah, I understood how to get the horizon value. I just missed on what you add to it to get the cash flow. So just wanted to double check.
Okay, yeah. So it's pretty much the same story all the way across here. In just about any of these, when we calculate the value, it's the last one of the dividends plus the horizon value of that same year. So what did we do in problem 23? We took the $1.152 and we added the horizon value of 31.04. That's how we got that. Yeah, so that's a good point to understand. What else can I answer?
Number 20, just a little more, just for the HV3 for year 4, please.
Okay. Let me.
I messed up on the homework, and I just want to make sure I cleared up my mistake.
Well, that's a good point to do. So oh, sorry. So guide me through this. I want HV4 for 24.
23.
Oh, 23. Sorry.
Or no, 20. I'm sorry. My
20.
fault.
Yeah, I'm putting words in your mouth. Sorry. Yeah. Okay. The Ryzen value.
You're still on 23.
Oh, you want 24?
No, 20.
20. Ah. Well, friends like me, who needs enemies, right? Okay. So I have dividend 1, dividend 2, dividend 3. There can't be much argument there. And then I changed the payout to 80%. And then that changes the growth rate to 20% times 11.5 or 2.3%. So let's just do that one live if we could. So with an 80% payout, I have a dividend of 6.02, and if we want to look nice, 0.29, let's say 7, divided by, okay, and then we have a cost of capital of 11.5%, and then minus the new growth rate. The new growth rate beginning from year 5 onward will be an 11.5% ROE times a retention of 20%. That's the whole of it, and we can do it again. We can also do, and like we'll see, so it would be $6 and 0.0297, and that would be divided by 11.5% minus the growth rate, which at this point is 2.3%, and that would give me the same number. Now, did I answer your question?
Yes, you did. Thank you.
Oh, you're always welcome. Good to have questions here. Best part of a class is questions. All right. Anything else before we move to chapter 5? All right. I'm going to open the lecture notes for chapter 5, and you can get those from Canvas, which would be very nice if you had them open already. All right. And chapter 5 opens up. It says net present value and other criteria, other investment criteria. Okay, this chapter is about the actual methods, the mechanics of the methods for making an investment decision. And you notice it says net present value and other. So it doesn't say net present value, comma, IRR, comma, accounting rate of return, comma, payback period, comma, discounted payback period. It says NPV and basically saying and the rest. All right. So the chapter is trying purposefully to put an emphasis on NPV. Okay, so if you walked out of Finance 320 remembering nothing about capital budgeting except that, oh, I think they told us to use the NPV, you learned enough. That was right. If you forgot these other methods, well, in order to make a correct investment decision, you know enough. Okay, but my goal here is to expand upon that and just to show you how the NPV relates to the IRR. And the reason I've included the IRR and not those others is that I just saw a survey of what discounting or what type of methods most companies use. And the survey showed that an equal number of companies used NPV and IRR, and just about the same number of companies used both. So those are going to be around for a while, those rates. So we have to understand, how does IRR relate to NPV? Okay, and if you're going to have a method which is valid, it has to have some characteristics. Okay, first of all, it must be discounted cash flows. So it must, when you say the time value of money, that means it must use discounted cash flows. All right, and if you read through the accounting rate of return method or the payback period, neither one of those discounts the cash flows. So those are eliminated. It includes all cash flows. All right, now let's just do something we can do in our heads. We're talking about this over a little bit of cool foamy beverage. And I'm telling you, I've got an investment we can get into for $100. We'll get back 50 the first year and 50 the second. Well, the payback period then says, how long does it take to recover the investment? Well, 100. I get back 50 the first year, 50 the second. It took 2 years to get it back. All right. Now, what happens if the third year cash flow goes negative or goes to zero? Fourth year cash flow is very small. We have no idea from the payback period, because once the initial investment is recovered, the payback period basically goes to sleep. It doesn't look beyond that. And you can't do that. You have to include all cash flows. Okay, and that eliminates the payback period. And then another way of doing this payback period is sometimes you can add up the present value of the future cash flows and see how long it takes to recover the initial investment. And that's no better. So, and then the next thing is conceptually strong underpinnings for its accept reject standard. Okay, what's a good number for a payback period? Well, I think of course you want it as small as possible, but does that mean if I have a payback period of 3 years, I should reject something? As a side, this is strictly a side note. That's not necessarily true, but when you look at these angel investors, and they have a method called the build-up method for the cost of capital. And if you're a very small business and you're trying to use angel funds, it wouldn't be at all unusual to see a cost of capital. I mean, they're going to discount your cash flows at around 33%. So what does that tell me? They want their money back in 3 years. All right. Is that necessarily a good criteria? No, it isn't. But that's just the way they do it. I mean, you have a steep cost of capital if you go that route. All right. So what's so good about the NPV? Well, the NPV uses the cost of capital. So in other words, if I'm funding a project with these dollars costing this much, then if this project doesn't return at least that much, why would I do it? And the answer would be, well, you wouldn't unless it did. And then the excuse me, the IRR method says that the IRR must exceed the cost of capital. And again, the cost of capital is a very conceptually strong, and it's a strong and well thought out way of coming up with a criteria. You simply must recover the rate that you're paying for the money. I mean, if I had a 5% savings account, I took the money and put it in an investment that earned 3%. How would that make sense? You see, it doesn't. All right. All right, so let's do a little example here. So what I'd like you to do is take this take this table and copy it into a blank Excel sheet. And just so we're all in the same area, let's drop this into the upper left-hand corner. Can we do that? So I'm going to copy this. And I'm going to try to go slowly enough so that you can follow this. So I'm going to go to Excel and I'm going to open a new sheet. I'm going to paste this into the upper left-hand corner. Oh, I don't like that. Let me use my... Okay, there we go. Now I'm going to blow this up so you can see it. Okay, I have a large project, L, costs 300, generates cash flows of 30, 180, 240 next 3 years, and a small one, invest 200 less, generates cash flows of 70, 80, and 10. All right, so first of all, let's find ourselves some common metrics, and that would be, we'll start out with the NPV, which is the best one, and let's also do the IRR. All right, now what I'd like you to do, calculate the NPV and the IRR for these two projects, and when you refer to a discount rate, this is the weighted average cost of capital, this is R. Oh, I keep forgetting. Yeah, dumb thing. This is reserved. So you can't use that. So let me get rid of my parentheses. I can say R, and I'll get away with that, but I can't put the parentheses. Isn't that amazing? Anyway, so our discount rate is 10%. So when you refer in your equations to the discount rate, lock cell B2, or B1, forgive me. Lock cell B1. Okay, so I'll start out the first one with you. Equals. We'll use the NPV function. And I think I've mentioned this in class, but the NPV in Excel is not net present value. So I'll do first of all the discount rate. I will lock it, F4, Command T, or whatever kind of machine you have, followed by a comma, and then the values. So I'll highlight, now you notice what it says? If you can see it there, it says value 1, does not say value 0. So I'm going to start with the 30 and highlight these three cash flows. All right, and then on the end, I still have to subtract the initial cost. Well, since the cost is expressed as a negative number, I'll just add it. And of course, Excel is always very willing to give you more decimals than any human would need. Okay, now let's do the IRR for the first one. Now, IRR, thankfully, is exactly what you do in your calculator. Equals IRR, and the first cash flow that you highlight is cash flow 0. So this works. And okay, now is that 17.51 or is that 18.49? I don't know. So why don't we give it a couple decimals? Oh, it's 18.13. So give your percentages 2 decimals. It's always a pretty good idea. At least 1, but certainly 2 wouldn't hurt. All right, now I'll do the exact same thing for the small project. Okay, let's make sure we're keeping up on this. Did this work? Anything? Oh, thank you. Okay, sounds like it did. Good to hear. All right, let's go back and pick this up. All right. Now, visually, what kind of issue are we looking at here? This one has the higher NPV. This one has the higher IRR. Okay, which one do I choose? And again, if you woke up just a little bit in the 320 class, your instructor would have said, choose the one with the highest NPV. And that is pretty much correct. I only say pretty much, and that is because there's always the boundaries of common sense. We had one time the CEO of Hutchinson Technology spoke to our classes, and he asked, why do you start your own company? Because he started Hutchinson. And someone said, I'd like to find employment for people in the small town I live in. And he said, that's a very nice thing to do. The next one said, I think I can get 40% of the market share within the next 3 years. And the class just kept putting in those types of answers, and pretty soon he put a halt to it and said, well, Those are noble, but none of them are correct. There's only one reason to start your own company. And then, honestly, I wish I had his voice, but he said, and that's to make, and he went a lot. And when he said a lot, he emphasized it, to make a lot of money. If you just want to make some money, work for someone else. That's not a big deal. If you want to start your own company, you make a lot of money. And then, you're thinking, is this American greed showing at its best? No. I knew a guy that started a concrete company, and he mortgaged his house, he mortgaged his car, he mortgaged every asset he had. He borrowed from his brothers and sisters. He borrowed from friends. He borrowed from banks. He borrowed from every source he could find. And he buys his first concrete truck and a mixer in a mixing plant. And next thing you know, he has a fleet of 40 trucks, and he's doing quite well. All right, but when he first started, look at the capital that he put at risk. He has his house at risk. He loses his house if this doesn't go. He has his brothers and sisters' capital at risk. So what he was saying is, if you're going to put these people's money at risk, make sure it's for a good reason, a very good reason. All right. So in the same vein, we have to apply some common sense to this seemingly mechanical rule of choosing the highest NPV. So if I have $1,000 at risk and I'm earning $10, and I have another investment which puts only $100 at risk and it earns $8, well, sure, the first one looks like has a higher NPV, but you have way more capital at risk. So always, don't be afraid to apply some common sense to some of these. All right, now let's continue onward here. What I'd like to do next is let's create a third column. And we're going to subtract the cash flows of the large of the small project from the large project. So let's do that. So we're going to say equals minus 300 minus 100. What does that tell me? That tells me that I'm investing 200 more in the large project than I am in the small one. Does that make sense? So what do you get in return for this additional investment? Well, the first year, you're now out $240, okay, because you're going to lose an additional 40. The year after that, now you're up. It has a $100 positive cash flow compared to choosing the small project. And then last year, it flourishes. So let's take our two metrics here, IRR and NPV, and extend those to the differential cash flows. Okay. So we'll get back to all these in a little while, but we're going to create a right now. This one has a higher NPV. Would I always, forever, choose L over S? And let's be a little more specific. For all costs of capital, would I choose R over S? And the answer is no, I wouldn't. Okay, so what I'd like you to do is come down below the IRR and just simply set it equal to one cell above there, the NPV. Okay, and copy this across. And for this time, we won't worry about all these extra decimals. All right, now just follow me. And below that, I'd like you to start with discount rates, possible discount rates. We're going to start with 0 and put percent on that, even though 0 and 0% are the same thing. Then go to 1%. All right. Now there's a feature of Excel that if you give it two constants and copy it, it'll continue to increment it. So if I copy this down one more, it's going to say 2%. If I copy this down one more, it's going to say 3%. Okay, so what I'd like you to do is extend this all the way out to 40%. So I won't be able to see mine, but I can get pretty close. Okay, so I'm going to stop at 40%. All right, now this is what I want Excel to do. I want Excel to enter 0% into my cost of capital and then recalculate these NPVs. I want it then to do 1% as the discount rate and recalculate these NPVs. All right, so rather than write out equations, what we will do, there's a function in Excel that you should know, and it's called the data table. Okay, so the first thing we'll do, highlight the first 4 cells of this row. Just highlight those. Can we do that? All right, then, at least in the PC environment, I'm not so sure in the Macs, but if I hit Shift, Control, and down arrow, Shift, Control, down arrow, it highlights the whole range. And if that doesn't work for you, you can just highlight the whole range. We can do that too. Doesn't take that much more time. Excuse me. Excuse me. So one way or the other, oh boy, highlight this area. All right, and then if you go into data, and there's something called what if analysis, and there's something called data table. All right. Now, I won't get into all the details, but we can actually, like I have 1, 2, 3, all these different percentages here. I could have another criteria I'd like to change. But instead, I'm going to change these discount rates for these 3 different calculations. So skip the row input, go down to the column input. And where would I want Excel to place all these different discount rates? I'd like to place them in B1, wouldn't I? And then see what happens. So it's easier to do. Just click on B1, and it should fill this entire table out for you. All right, so there you go. All right, well, we don't need this yet. I mean, well, we got better things to do with this. All right, what I'd like to do now is highlight starting with 0%. So you can do the same little thing I just did earlier. Shift, Control, down arrow. Or if you just simply highlight the area. Okay, and just highlight these. There aren't that many. Okay, highlight these. And then we are going to graph them. So let's go into Insert. And now when you have a mathematical relationship between 2 points, you want to graph what's called an XY scatter. That's this one. What if I had somebody sold 20 cars in January, 30 cars in February, 40 cars in March, and I wanted to graph that? Well, there's no mathematical relationship between the cars and the month, is it? That's a line graph or a bar graph. But here we have a distinct mathematical relationship between the discount rate and the NPV. All right, so we're going to graph a XY, and let's pick the smooth lines. And it should give you a graph that looks like this. And then we'll beautify it a bit. We'll take out the vertical lines. We'll take out the horizontal lines, just delete them, highlight them, delete them. All right, if you edit the chart table title, we'll call this the NPV. It's called a profile. All right, and then you see Series 1, Series 2, so that's not very informative, is it? Okay, so I'd like you to do, I'm going to go up to the the first line and double click it. You see how it shows me all the X's? You don't need this. I don't need that. Okay. And I'm going to right mouse it. And then I'm going to say select data. Okay, we've already selected all of our data. That's all done. But what I want to do is I'm going to edit this series and just give it a name. So this is project L. Say okay. Let's do the next line, which is project S. Edit. And then okay. And then find the last one. What do you think I'll name this? How about L minus S? I'll say okay. And then we'll say okay. And now you have just a very fine looking graph, don't you? All right. Now from this graph, we can see many, 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 many things. For example, on this axis, we have the NPV. All right. This is your NPV. You can see this is 0 NPV, isn't it? So anytime these lines drop below the x-axis, you're saying no to that investment, right? So can you see very clearly that if I pick a cost of capital of 25%, I would not be funding the large project, would I? Okay. But do I know that anyway? Well, sure. Look over here. The IRR for project L is 18.13%. 25% exceeds the IRR. Therefore, I would reject it, wouldn't I? Okay, so if I back up this blue line, back up, and I come to here, this is where the NPV is 0. And at this point, you would find the discount rate is exactly 18.13%, which is the IRR. And let's just prove that to ourselves. So if I said for my cost of capital equals, and I highlight my 18.13%, watch what happens to NPV. It goes to 0, doesn't it? This is 0. It's just a different formatting. Okay, so let's go back to 10%. All right, and how can I make this happen for the small project? Well, its IRR is 34.83. You see, that's way out here, isn't it? It's about right here. So if the cost of capital exceeds 34.83%, I should be rejecting the S project. So we can prove that. Let's set our discount rate equal to 34.83%, and look what happens. Okay. So yes, I would say no to that project at that rate. That's a very high rate though, isn't it? All right. So what a profile tells you is it compares the NPV to the discount rate. All right. And there's one very important discount rate here. And that rate would be 13.44%. Okay, that's L minus S. You see this L minus S? The gray line. I follow this down to the origin, the x-axis, not the origin, the x-axis. And it says 13%, but it really isn't. It's 13, it's right here. 13.44%. Okay, that's the point at which these two profiles cross. That's the point at which these two will have exactly the same NPV. And let's prove that to ourselves, because we don't believe that kind of a thing. So if I set the cost of capital equal to 13.44%, do you notice that going across here, I'm getting $30.72. Okay, so what is this? It's called the crossover rate. What is it? It's the rate at which the two projects have the same NPV. But then you call it the crossover rate because why? This is where we change the project that we would choose if we could only take one. If you just stay on the highest NPV. So from here to here, the highest NPV is blue. Now all of a sudden, the highest NPV is brown. And then that only goes to 34.83%. And then none of these lines are positive NPVs. Okay, so we have three distinct zones here. We have from 0 discount rate all the way out to where these two cross. That's one specific zone. We have from that point all the way out to 34.83. That's another zone. And then beyond that is the third zone. And we will pick this up on a Thursday, and we'll fill in those zones. So I have a few minutes left here. I can help somebody catch up if you got behind. Let me know if you have a question.
Yeah, I do have a question.
Okay.
Could you help me fill out the table?
Oh, we could. What did you not do?
I didn't have the tab to fill it out.
Okay, do you have this?
Yes, I do.